Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with 3D projections of a solid in which the front view face, the top view face and the right hand side view face of the solid, they have been combined into a single 3D isometric projection over here. So using the information available with us through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of this object. Now, in order to obtain the orthographic projections of this object, we are required to evaluate the dimensions of front view face, the top view face and the right hand side view face of the solid. As we are going to look at the solid from the front view orientation, we observe that the width of the solid happens to be equal to 112 millimeter, while the height of the solid happens to be equal to 55 millimeter. So the front view face dimensions we are going to obtain as 112 millimeter by 55 millimeter. As we are going to look at the solid from the top view orientation, we observe that the width of the solid, it is equal to 112 millimeter, while the depth of the solid happens to be equal to 60 millimeter. So the top view face of the solid will be measuring 112 millimeter by 60 millimeter. Similarly, when we are going to look at the solid from the right hand side orientation over here, so we are going to observe the depth of the solid equal to 60 millimeter and the height of the solid equal to 55 millimeter. So the right hand side view face of the solid will be measuring 60 millimeter by 55 millimeter. So with this information, we are required to obtain the orthographic projections of the solid over here. So here we have got the XY reference line, the X1, Y1 reference line, and we have also obtained a transfer line inclined at an angle of 45 degree with respect to the XY reference line in such a way that we should be able to transfer the distances alongside the depth into the top view projections in the right hand side view projection view over here. So since we are going to obtain the orthographic projections of the solid into the first angle projection method, so the front view projections of the solid will be obtained above the XY reference line. The top view projections of the solid, they will be obtained below the XY reference line, and the right hand side view projections of the solid, they will be obtained on left hand side of the front view orthographic projections over here. So now we know that when we evaluate the construction of this engineering object, we can divide this object into three elements over here. So the element number one, it happens to be a horizontal wave which is lying at the base of the solid over here. So this is our element number one, which is having the dimensions width, it is equal to 112 millimeter, the depth, it is equal to 60 millimeter, and the height, it is equal to 12 millimeter. And this horizontal wave, it is carrying two holes which are symmetrical in nature. So these two holes, they are having diameter is equal to 15 millimeter. So they are located symmetrically around the center line of this particular object over here. Then we have got element number two, which happens to be a vertical wave which happens to lie on the rear side of the solid. And this element number two, that is vertical wave, it is having two inclined surfaces on either ends over here. That is, onto the left hand side also we have got one inclined surface at the top. Similarly, on the right hand side of this particular vertical wave, we are having an inclined surface at the top over here. So then we have an element number 3. So this element number 3, it is once again located on top of the horizontal wave, which is our element number 1. And this element number 3, it happens to be a triangular wave which is obtained perpendicular to the front face of the solid over here. And we are going to have the width of this wave equal to 12 millimeter. So with this information, let us proceed to evaluate the orthographic front view projections corresponding to this solid over here. So we know that the width of the solid, it happens to be equal to 112 millimeter. So we have marked this width into the front view projections over here. So here we have drawn two vertical projector lines which are separated by the distance equal to the width of the solid equal to 112 millimeter. And these two vertical projector lines we have marked into the front view projections, and we have extended these two vertical projector lines into the top view projections as well. The reason behind this extension is because into the top view also the width of the solid we are going to obtain as 112 millimeter. So we know that the height of the solid happens to be equal to 55 millimeter. So now we are going to draw a horizontal projector line into the front view projection view such that this horizontal projector line, it is located at a distance of 55 millimeter above the XY reference line. And this horizontal projector line we are going to extend it into the right hand side view projections as well, because into the right hand side view projections height of the solid will be equal to 55 millimeter once again. So this way the front view face of the solid measuring 112 millimeter by 55 millimeter we have been able to obtain. So we know that the dimensions of the solid into the top view projections, it is 112 millimeter width and 60 millimeter it is the depth of the solid. So now into the top view projections, once again we have drawn two horizontal projector lines over here such that these two horizontal projector lines, they are separated by the distance equal to 60 millimeter, which happens to be the depth of the solid over here. And these two horizontal projector lines, we have transferred them into the right hand side view projection view such that we are able to obtain this width of the solid into the right hand side view projection view over here as 60 millimeter over here. So now we have been able to obtain the top view face of this solid as 112 millimeter by 60 millimeter, and the right hand side view face of the solid we have obtained as 60 millimeter, it is the depth of the solid, and 55 millimeter it is the height of the solid over here. So this way the front view face, the top view face and the right hand side view face of the solid has been obtained into the orthographic projections over here. So now let us start with element number 1. So we know that element number 1, it happens to be a horizontal wave which is lying onto the base of the solid. Now we know that the height of this wave, it happens to be equal to 12 millimeter. So we have marked this distance of 12 millimeter from the base or the ground, and we have drawn a horizontal projector line at a distance of 12 millimeter from the XY reference line into the front view projections, and extended this horizontal projector line into the right hand side view projections as well. So now another thing we know that there is an inclined triangular wave which happens to lie at the center of the solid. So this is our element number 3, and this element number 3, it is located centrally alongside the width of this particular solid over here. So we know that the width of the solid is 112 millimeter. So the center line corresponding to this width into the front view, it is at a distance of 56 millimeter from the left hand side face of the solid. So this is the left hand side face of the solid over here. Now from the left hand side face of the solid, we have measured a distance of 56 millimeter. As we move along this particular solid towards the right hand side face of the solid, now we have marked a center line into the front view projections at a distance of 56 millimeter from the left hand side view face over here, and we have extended the center projection line into the top view projections as well. And now we know that the width of this triangular inclined web, which is located centrally on top of this horizontal web, it happens to be equal to 12 millimeter. So from the center line, we have taken an offset of 6 millimeter on either side, and we have marked this distance of 12 millimeter corresponding to the width of this inclined triangular web over here. Now we can check that this inclined rectangular web over here, so this is going to be projected as an apparent shape into the front view projections over here. So this projection, which is a rectangular shape projection, it will be apparent shape projection corresponding to this rectangular surface of this inclined triangular web over here. So now we have been able to obtain projections corresponding to element number 3 into the front view projections as well. And another thing, we know that there are two holes which are located symmetrically into the horizontal web, which happens to be our element number 1. That is from the center point at a distance of 32 millimeter towards the left hand side face, and at a distance of 32 millimeter towards the right hand side face over here. So the center lines corresponding to hole number 1 and hole number 2, they will be located over here, so that the distance between these two center lines corresponding to these two holes, they should be separated by a distance of 64 millimeter over here. So now we can check. We have taken offset of 32 millimeter onto the left hand side, and 32 millimeter offset we have taken towards the right hand side face of the solid. And again, two center lines we have been able to obtain into the front view projections, and we have extended the center lines into the top view projections as well. So this way we have been able to locate center corresponding to the hole number 1 and hole number 2 into the front view projections over here. And now we know that the diameter of the hole, it is equal to 15 millimeter. So from this center line and from this center line, now we have to take 7.5 millimeter offset onto the left hand side portion, and another 7.5 millimeter offset towards the right hand side face of the solid, so that we can obtain the projections corresponding to these two circular holes which are obtained into the horizontal wave which is lying onto the base of this particular solid over here. So now at a distance of 64 millimeter, we have already evaluated the center points of these two holes. They will be located over here, and then by taking offsets of 7.5 millimeter on left side and 7.5 millimeter towards the right hand side, now the location of the holes we have been able to obtain into the front view projections over here. And another thing we should remember over here, these holes, they will not be visible to the observer, as the observer is going to look at the solid from the front side. So here hidden line projections we will be obtaining corresponding to these holes into the horizontal web, which is having height is equal to 12 millimeter over here. Now we have to obtain projections corresponding to element number 2 over here. So we know that in case of element number 2, we are going to have two slant surfaces. One slant surface is located towards the left hand side top portion, and another slant surface is located on the right hand side top portion of this vertical web over here. Now we have been provided with the orientation of these two inclined surfaces. That is, the inclined surfaces, they will be starting at a height of 32 millimeter from the base or 20 millimeter from the top of this horizontal surface. So either way around, now we are going to take height of 32 millimeter over here. But before that, we can check this rectangular face which is corresponding to the base web or the horizontal web. The true shape of this surface will be represented as a rectangular projection into the front view projections over here. Similarly, as we have already discussed, these two circular holes which are having diameters equal to 15 millimeter, they will not be visible to the observer into the front view projections. So we are going to obtain dotted line projections corresponding to these two holes over here. That is the hidden line projections we have been able to obtain. Now we can check, we have taken the height of 32 millimeter from the ground, and at the height of 32 millimeter from the ground, we have marked a horizontal projector line into the front view projections, and we have extended this projection line into the right hand side view projection view over here. Now we know that from the left hand side point corresponding to this projector line, we have got the starting point of this inclined surface over here. Similarly, corresponding to the right hand side corner corresponding to this particular projection line, we have got the starting point corresponding to this inclined surface over here. But what is the angle of inclination for this inclined line? It happens to be equal to 45 degree. That is, from this point and from this point, we are going to draw two inclined edge view projector lines over here, such that this angle of inclination of this inclined surface with the top face of the solid, it happens to be equal to 45 degree over here. Similarly, from the right hand side also, from this starting point which is existing at a height of 32 millimeter from the base, again one inclined surface edge view line we are going to obtain, which will be inclined at an angle of 45 degree with respect to the top surface over here. And then once we locate these two top face intersection points corresponding to this surface and corresponding to this surface over here, so now this remaining portion of the top surface we can join as a straight line, which is going to represent the front view projections corresponding to this rectangular surface over here. So this rectangular surface will be projected as an edge view into the front view projections over here. Another thing we will be witnessing in this particular case, that this inclined rectangular surface corresponding to element number 3, which we are going to obtain into the front view projections as apparent shape rectangular projections over here. So now here we have been able to obtain the apparent shape projections corresponding to this wave which is lying perpendicular to the front face of the solid over here. So since this surface, it happens to be inclined with respect to the vertical plane, so the projections of this rectangular surface onto the vertical plane will be projected as apparent shape projections into the front view projections over here. Now let us proceed to evaluate the top view projections of the solid. Now as the observer is going to look at the solid from the top, so we observe that this is the depth of the element number 2 over here. This is our element number 2, which happens to be a vertical web, which is carrying two inclined surfaces at the two ends of the vertical web. Now, corresponding to this vertical web, which is parallel to the front face of the solid, here we have got the depth of this web. It is equal to 12 millimeter. So now, from the rear face of the solid, we have marked a distance of 12 millimeter as we move towards the front face of the solid over here. And corresponding to this distance of 12 millimeter from the rear surface, we have drawn a horizontal projector line into the top view projections, and we have transferred this projector line into the right hand side view projection view over here. So now we also know that there are two holes which are carried into the horizontal web, which happens to be our element number 1. So the one center line we have already obtained through the front view projections over here. Another center line projection we have already obtained through the front view projections over here. Now we know that the location of the center of this hole, it is available at a distance of 24 millimeter from the front face of the solid. So this is the front face of the solid. So from the front face of the solid, we have measured a distance of 24 millimeter, and another center line we have been able to obtain at a distance of 24 millimeter from the front face of the solid, and we have transferred this center line into the right hand side view projection view over here. So this way, the center point corresponding to these two holes, it has been located over here. So corresponding to center point number 1, a circular hole projection has been obtained into the top view projection over here. And what is the diameter of the circular hole? It is equal to 15 millimeter. Similarly, from the second center point, we can draw a circle having radius 7.5 millimeter or diameter 15 millimeter over here. Now we have been able to obtain the top view projections corresponding to these two circular holes over here, which are having diameter is equal to 15 millimeter. So now the projections we have marked corresponding to this diameter and this diameter of the hole into the side view projections as well, so that we'll be able to obtain the projections corresponding to this hole into element number 1, as we will be looking at the solid from the right hand side view direction over here. So now when we look at the solid from the top, so the boundary of this solid will be visible to the observer from the top view projections over here. Another thing, since we have already evaluated that the depth of this web, it happens to be equal to 12 millimeter. So corresponding to this depth, we have obtained a rectangular projection corresponding to element number 2, which is a vertical web which happens to be parallel to the front face of the solid. And we also know that this vertical web, it is carrying two inclined surfaces. One surface is available on the left hand side face. Another inclined surface is available towards the right hand side face of the solid. Now we have already obtained the location of starting point of this inclined surface and end point of this inclined surface over here into the front view projection. So once we draw these projectors in the downward direction, now we can see this is the top view projection corresponding to the inclined surface, which is available towards the left hand side face of this particular solid. And now, since this inclined surface happens to be inclined with respect to horizontal plane, so the projections of this inclined rectangular surface onto the horizontal plane will be projected as apparent shape projections into the top view projections over here. Similarly, there is another inclined rectangular surface which is available at the top portion of this vertical wave, and it is located towards the right hand side face of this particular solid. And once again, since this rectangular surface happens to be inclined with respect to horizontal plane, so its projections onto the horizontal plane will reveal the apparent shape projections of this surface over here. Whereas this rectangular surface, it is located centrally on the top surface of this vertical web over here. And since this rectangular surface located at the top surface of this vertical web, it happens to be parallel to the horizontal plane, so the top view projections corresponding to this flat surface, it will be the true shape projections which will be projected onto the horizontal plane. So this way we have been able to obtain projections corresponding to element number 2 over here into the top view projection. And now let us obtain projections corresponding to this inclined rectangular surface onto the horizontal plane. So here we have got element number 3, which happens to be perpendicular to the front face of the solid, and this inclined rectangular surface will be projected as an apparent shape projections into the top view projections over here. So this way we have been able to obtain the top view projections corresponding to all the 3 elements of the solid. Now when we look at the solid from the right hand side view, so we will check that this L shape projection, that is, this is the projection corresponding to the horizontal element. This vertical projection is corresponding to element number 2 over here. Now into the element number 2, we obtain that this surface happens to be parallel to the profile plane, so it will be projected as true shape into the side view projections over here. Even this surface corresponding to element number 1, this is also parallel to the profile plane, so this surface, which is an L-shaped surface over here, so this has been projected as true shape projection into the profile view projection over here. Whereas corresponding to this inclined surface, because this rectangular inclined surface, it happens to be inclined with respect to profile plane as well, so into the right hand side view projections onto the profile plane, we are able to obtain the apparent shape projections corresponding to this inclined rectangular surface over here. And another thing we observe over here, there are 2 circular holes which are aligned with each other into the side view projections over here. So these 2 holes, they will be overlapping with each other. So into the side view, we are going to obtain hidden line projections corresponding to these 2 circular holes having diameter is equal to 15 millimeter. Now finally, corresponding to this element number 3, which happens to be an inclined triangular web over here. So corresponding to this triangular web, since this surface, it happens to be parallel to the profile plane, so when we join this corner point with this corner point, we are going to obtain triangular true shape projections corresponding to this perpendicular web, which is perpendicular to the front face of the solid over here, into the profile plane view projections over here. So this way, into the right hand side view projections, this triangular projection will be representing true shape projections corresponding to this element number 3 or the triangular web over here. So this way we have been able to obtain orthographic front view projections of the solid, the orthographic top view projections of the solid, and the orthographic right hand side view projections corresponding to this engineering object over here, using the information available with us through the 3D isometric projections over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids into the coming lecture classes. So thank you very much. Thanks a lot.